The rest of the handout is actually examples that I pulled straight from my math lab because I wanted you to be able to see how you're going to work out these problems on the computer and not so much pencil and paper. Okay, so number 1 says determine the amplitude of the following function. Then graph the function y equals sine of x in the same rectangular coordinate system for all values of x between 0 and 2 pi. Okay, so we have the equation y equals 3 sine of x. So the amplitude, remember this, the coefficient of the sine is a, so the amplitude is the absolute value of a, so that would just be 3. Now it says determine which graph shows y equals sine of x and y equals 3 sine of x. And it tells you that it's different colors, which we can't see here, but you will on your homework. So the first thing I'm going to look for is where do I find y equals sine of x? Well, I know it's going to pass through 0, 0, so that's all of these. I know I'm going to have a period of 2 pi, so again, that's every graph here has a period of 2 pi. My amplitude is 1, so in the dotted line, I'm looking for this curve, so I can see all of those fit that description. So where is y equals 3 sine of x? Again, my height or my amplitude is going to be 3, so that can eliminate a. I know that sine should be an increasing first and then decreasing. Because this is not a reflection, I can eliminate b. Okay, I can eliminate c for the same reason, doesn't have the right amplitude, and it's not a reflection, so it must be d. Okay, so I have the sine wave with an amplitude of 3 and a period of 2 pi, so the answer is D. Okay, number 2, almost the same equation. Okay, y equals negative 3 sine of x. Again, my amplitude is the coefficient of the function, so it's the absolute value, so it's 3, even though this is negative 3. This being a negative 3 lets me know that this graph will be reflected about the x-axis. So this is a reflection. So again, the dotted line, the dashed line, should represent y equals the sine of x, and the solid line should represent the function given here. So again, I want to check the periods. They're all 2 pi. I want to check the amplitudes. I need an amplitude of 3 so that I can eliminate D and I can eliminate A. Okay, now so it's between B and C. Well, I know that this graph is a reflection because of the negative 3, so that means it would be B. Instead of the graph going up normally as it would, because it's a negative, it's going to be reflected and look the opposite. So the answer would be B. Okay, number 3, we're going to determine the period and the amplitude and then find the graph. So again, the amplitude is your coefficient, so that's just 4. The period, okay, remember on the previous page it says the period is equal to 2 pi over b. Well, b is going to be the coefficient of your variable, okay, of x. So that's pi. So this means my period would be 2 pi over pi. Pi's divide out, so I have just a period of 2. And so that can help you when you're trying to find your correct graph. I can automatically eliminate the ones that have a period of 1 here, since it says this is a complete wave from 0 to 1, from 0 to 1. So it's not A and it's not D. Okay, now I have to choose between these. Do they have which one? Do they have the correct amplitude? Okay, they both have amplitudes of 4. This is not a reflection, so that can eliminate C. D is the correct answer. Okay, number 4 says determine amplitude, period, and phase shift. Okay, we can determine that from looking at our graph. The amplitude is the coefficient of the sine function, so that has an understood 1. The period, 2 pi over b, So what is my b value? B is the coefficient of the variable, okay, coefficient of x. So 2 pi over 2 gives me a period of pi. Okay, the phase shift is negative c over b. So negative c would be pi over 2 divided by b, which is 2. Okay, so if I have negative pi over 2 divided by 2, that's negative pi over 2 times 1/2, so that's negative pi over 4. Okay, so my phase shift would be negative pi over 4. So if I look at my graph, first I'm going to check amplitude. All of these have an amplitude of 1. Then I'm going to check my period. Which ones have a period of pi? Okay, well, A has a period of pi, and so does B and C. The distance from negative pi over 4 to 3 pi over 4 is 1 pi. The only one we can eliminate so far is D. Okay, then I look at, this is not a reflection, so that means I could eliminate B. There is a phase shift. Okay, graph A does not have a phase shift, still passing through the origin. If we notice C, this graph has been shifted from the regular position to the left pi over 4 units. So the correct answer would be C.